We have a couple of other formulas that are used. These are usually taught toward the end of the factoring sections. But this is when you have the sum or difference of perfect cubes. And these formulas go like this. So if you have a cubed here, if you have a cubed plus b cubed, in other words, if you have the sum of two perfect cubes, they're going to factor into a plus b times a squared minus ab. Now notice this is minus ab, not minus 2ab like it was for the trinomials, perfect square trinomials. So it's a squared minus ab plus b squared. Now if it's the difference of perfect cubes, it's going to factor into a minus b times a squared plus ab plus b squared. Now the way I remember these two formulas is I always remember that the sign of the binomials are the same. So if you look at the binomial here that we're factoring, this is a sum. And if you look at the result, the binomial factor portion of this is also a sum. But if you're dealing with a difference of cubes, then the binomial is a difference. And then I'd always remember that whatever the sign is here for the b term, then it's going to be opposite for the ab term. So therefore I can say, okay, a cubed plus b cubed, since the binomial is a sum, then that's going to factor into a plus b, and then times a squared minus ab plus b squared. And if it's a difference, it's going to factor into a minus b times a squared plus ab plus b squared. So here are some examples of perfect cubes here. So let me highlight some of these for you. X cubed plus 8y cubed. X cubed is a perfect cubed, and 8y cubed is a perfect cube. 16m cubed minus 27n cubed. That's actually the difference of two cubes, because 64m cubed is a perfect cube and 27n cubed is a perfect cube. And then if you take 1000 minus 125x cubed, that's the difference of two cubes. And then if you take 8t to the 6th minus 1, that's the difference of two cubes. And then here you have another difference of two cubes here. I don't know why I did so many differences, but I probably should have done a sum in there somewhere. And actually I think I do in the examples. Kind of mix it up a little better. But anyway, let's look at some examples here. Okay, so here let's talk about how we would factor x cubed plus 8y cubed. Now what I tell students is, if you know this is a perfect cube and you know this is a perfect cube, you may not have to write it down, but think about what is cubed to give these. So this one's easy. You just cube x to get x cubed. But what do you cube to get 8y cubed? You actually have to cube 2y. So since you cube x to get this, then a would be x in the formula. And then since you cube 2y to get this, then b would be 2y. And now you just go to the formula a cubed plus b cubed. It factors into a plus b, which would be the x here plus 2y. That's the a plus b. And then you do x squared minus ab. Now, so you do minus the product of x and 2y, which would be 2xy, and then plus the square of 2y, so plus b squared. So you square the 2y, and you get 4y squared. Okay? All right, now the next one is actually a difference of perfect cubes, because 64m cubed is the same as 4m quantity cubed, and 27n cubed is the same as 3n quantity cubed. So in this case, a would be 4m and b would be 3n. So the formula for factoring a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So the a minus b would simply be the 4m minus 3n here, and then the a squared, you would square 4m and get 16m squared, and then you would add to that ab, so that would mean you would multiply 4m times 3n and get 12mn, and then you would square the 3n and get 9n squared, because you have to get, because of the b squared has to be the last term. Okay, now the next one is another difference. So this one is 27 minus 125x cubed. Well, 27 is 3 cubed, and 125x cubed is 5x quantity cubed. So here a would be 3 and b would be 5x. And again, this is a difference, so we use the same formula we used on the previous problem. So I would do a minus b, so that'd be 3 minus 5x, plus a squared, so I'd square the 3 and get 9, and then plus ab. So ab would be 3 times 5x, which is 15x, and then plus b squared, which would be 5x quantity squared would be 25x squared. And so that's what that would factor into. Okay, now here is another sum. So we have 8t to the 6th plus 343. Okay, well, 8t to the 6th, that's the same as 2t squared quantity cubed. And 743 would be 7 quantity cubed, because 343 is 7 quantity cubed, because 7 times 7 times 7 is 343. So a would be 2t squared. Oops, I got to fix this. Hang on just a second. Okay, so I had to fix there. I'd left off the square here. So actually a is 2t squared, and b would be 7. So using the formula for a cubed plus b cubed, you would have a plus b, so that would be 2t squared plus 7, and then plus a squared. So if you square 2t squared, you actually get 4t to the 4th, and then minus the product of a and b, so that would be minus 7 times 2t squared, so that would be minus 14t squared, and then plus 7 squared, so that would be plus 49. Okay? Now, this next one, 64x to the 6th minus y to the 6th, it factors into, you can write that as 4x squared cubed minus y squared cubed, so that a would be 4x squared and b would be y squared. And so we would be using the formula for the difference of cubes. So we would say a minus b, so we'd have 4x squared minus y squared, and then times 16x to the 4th, because if you square 4x squared, you get 16x to the 4th, plus the product of these two, so the product of these would be 4x squared y squared, and then plus y squared squared would be y to the 4th. Now, we're not done yet, because 4x squared minus y squared actually factors as difference of squares. So we can factor that again into 2x minus y times 2x plus y using our difference of squares formula. Okay. Now, I wanted to just show you this. This last one I did could be factored another way. First of all, since this is difference of cubes, so I did it as difference of cubes up here, but it's also difference of squares, because actually 64x to the 6th is 8x cubed quantity squared, and y to the 6th is y cubed quantity squared. So what we could have done here is we could have factored this first as difference of squares, and if we did that, we would get 8x cubed plus y cubed times 8x cubed minus y cubed. Well, then you could factor 8x cubed plus y cubed as sum of cubes, which would give you 2x plus y times 4x squared minus 2xy plus y squared. And you can factor the 8x cubed minus y cubed as difference of cubes, so that would give you 2x minus y times 4x squared plus 2xy plus y squared. Now, you'll notice the answers, it looks like they're the same. You got the 2x minus y here and the 2x minus y down here. You got a 2x plus y here and a 2x plus y down here. But up here you have a fourth degree polynomial. Well, down here you have two second degree polynomials. Well, it turns out, guys, if you multiplied those two polynomials together, you would actually see it's the same as this fourth degree polynomial. So actually, you know, we could have argued that, well, maybe we could have factored this more here when we did it in this part, but we don't have the tools to factor fourth degree polynomials that are, you know, that complicated. We can't factor those at this point. So anyway, what I'm trying to say here is that in my classroom, if I asked you to factor this problem, I would accept either way, whether you factored it as difference of cubes first or whether you factored it as difference of squares first. As long as you went on and did the rest of the factoring, I wouldn't count off for it. Okay, so that pretty much completes the sections on factoring. The next video we'll talk about how to solve these polynomial equations by using these factoring techniques. So we'll solve equations in the next video.